All right, let's look at the last set of the word problem set. Oh, it's not on this sheet. Sorry about that. Let me find my. What was that? Not bad. How was yours?
I was just busy.
Yeah. All right, sweet. I did have it here. Okay, cool. Let's look at number 4. We'll start with 4 then. So a rocket is being launched from atop a 50-foot cliff with an initial velocity of 88 feet per second. 88. Joke with 88 miles per hour going back in time. It is not going very fast. At the height of the rocket in t seconds after launch is given by the equation blah 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 blah. Graph the equation to find out how long after the rocket is launched it will hit the ground. So here's what it's looking to do. You're already on top of a 50-foot or an 80-foot cliff, and you shoot the rocket. He goes. I saw this one. Anyway. I think it was. So what?
Over the announcements.
It's nothing but fun in here. Find out how long it takes the rocket to hit the ground. So you're looking for your time value to equal, your height to equal what? 0. Correct. You're trying to figure out where your height equals 0. Now, one thing that I'm going to have you guys understand, a lot of times when you're dealing with these word problems, one very easy thing to use to solve for these things, if you're looking to find a 0, use quadratic formula. Quadratic formula works with these things real fast, okay? Remember, you're using the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Oh, that reminds me, after this problem, I will play you the video from the other class that did the song.
Was that Hunter?
I'll do the song.
Yeah.
I'll do the
Have you
song.
seen it? Stephen Bell Rock. Oh, it's priceless. It's very good. I will show you that. It was due last week, but that would require writing things down. So what I do here is I'm going to start substituting my values. Because it gives you the function, so it's negative 88 plus or minus the square root 88 squared minus 4 times negative 16 times 80 all over 2 times negative 16. Now, what's happening here is if you look into the actual equation, if you graph this, your parabola is going to give you a 0 that's negative, you're going to have a 0 that's positive. So when you go through all of this, you wind up with negative 88 plus or minus 113.42 all over negative 32. Now, what happens now is that you get 2 solutions. Yes, sir?
Wait, what is our h 0?
Yes. We're trying to find out when height is equal to 0. When does a rocket hit the ground? That's what you're solving for. So what you're trying to figure out, when you find out what the height is equal to 0, that's going to give you your value of time. How much time is it? Because the height starts at 80, so you're already starting to figure out how long it takes to go. So when you look at this, you're dividing by a negative value. But you want a positive value of time, correct? So should I do negative 88 plus 113 or negative 88 minus 113? I should do the negative value. That way I get a negative value divided by a negative to give me the positive value of time. So when you do that, you get the 6.3 seconds. Okay? Remember, think about what it's asking you to find. You're trying to find amount of time. You're trying to figure out a positive value of time. So if I wind up with negative 88 minus 113, I will still have a negative value in my numerator. I have to divide that by the negative value to get my positive amount of time. Quadratic formula works real clean, real fast with this style of a problem. Did that make sense?
Is it 6.9?
I got 6.3. Oh. 6.3. Did you, oh, you know what, did you do 113.42?
Yeah. Oh, I didn't think.
There you go. It's really easy, to, just make sure, and that brings up a great point, guys. If you're using the quadratic formula, don't put it all in your calculator at once, you'll probably get it wrong. Do it in chunks, just like how I did here, where I just took care of the discriminant. Oh, remember that? Took the square root and I wrote that down. So that way, if you did write down this whole part, you gave me 6.9, I know that you've got bad fingers. But you know what you're doing. Does that make sense?
Yes.
Staring off into space. And then the number 5. Same idea with 5. It gives you the model, 18t squared plus 136t plus 6444. When time is equal to 0, starting in 1979. What year will the number of new cars purchased reach 19,000? So what you're doing here is you're trying to figure out when 19,000 is going to equal this. When that equals that. So from there, you set one side equal to 0 again. Uh, 12, 5, 5, 6. And you know that has to equal 0. So I'm trying to figure out my values of time, the amount of years. It's a parabola. It's probably giving me a positive and a negative value for this one. I'm not going to want to graph this because it's got awful y-intercepts and things like that. So again, to figure out my two values of my zeros, use quadratic formula. It's very quick, very efficient to solve this one with a quadratic again. Numbers are nasty, but that's okay. Negative 136 plus or minus the square root. 136 squared minus 4 times 18 times negative 12556 all over all over 2 times 18. So again, when I go through this one, I go to the calculator. Thinking. There we go. So we have 136 squared minus 4 times 18 times negative 12,556. That's my discriminant. Take the square root of that number. So then I have negative 136 plus or minus that. Now, what is my denominator? Is it a positive or a negative denominator? It's a positive denominator, right? So should I do the negative 136 plus this or negative 136 minus that? I gotta do plus. I have to do the plus because I'm looking for a positive value in time. Does that make sense? So if I take this value, because that's what's underneath, that's what the discriminant, or when you take the square root of the discriminant. So if I add to that the negative 136, there's my numerator. I have to divide that by 2 times 18, which is, and that gives me the number of years, 22.9 years. So at that point, I would say it's asking you for the value of how many, or what year will the number of new cars purchases reach 19,000? Well, if you do 22.9, you get 2001.9 years. So can I just say 2002? In the year 2002, that'll occur. Yes, sir.
How do you know if you need to, or how would you know if you need to add it or something?
Because when you start looking at, you're looking at time. Can you have negative time? That's why. I'm deciphering what is the problem asking me to find. Yes, you can use that for both types of zeros, but if I'm looking for just a positive value, like how many years will it be? I can't go backwards,
Yeah.
so I'm looking for that positive one. So that's why I make the decision, is it negative 136 plus, or is it negative 136 minus? And it depends upon, in this case, my denominator was positive, so I want my numerator to be positive. That's all.
Okay.
That's all it works out to be. Okay? Do the rest of those word problems on this one with the modeling work out okay? You don't have to go backwards. Unless you're in the DeLorean doing 88 miles an hour, yes, and the Libyans are chasing you. Are there any others on this? The rest of these okay? Fairly straightforward stuff, I hope, right? See the model, use the model. 4 on the front is nasty because of the fraction. Okay, let's take a look at 4 on the front. Number 4 on the front says complete the square.
It's so hard.
Okay, in order to complete the square, I need to have A equal to what? 1. Positive 1. A has to equal positive 1. So what I want to do here, and then you got to have A equal to 0, or A equal to 1, but I also have to move the value of C to the other side. That was the next step. So in this problem, can I add 8x to the left and subtract 35 at the same time just to get started on it? So I get 2x squared plus 7x. Oh, it's negative. That's right. It's negative 7 here. So this is 8. So we get negative 8x equals negative 35. Is that okay, what I did there? From that, I have to have a positive A value, which means what am I going to divide everything by? 2. Divide everything by 2, and you get x squared minus 4x blank equals negative 35 over 2. We okay with that? Now we start with the process of completing the square. When we complete the square, the very first thing you do is you take half of your b value. What's half of negative 4? Negative 2. So this value of negative 2 goes into my term, so it's x minus 2 quantity squared. Now I take that negative 2 and I square it. What's negative 2 squared? And what do I do with that 4? I add it to both sides. Very good. So I add 4 to both sides. Okay? Now, I have to figure out what negative 35 over 2 is plus 4. An easy way to do that is to rewrite this as 8 over 2. The reason why I did that is because it's just a simple fraction to work with. This is going to give me, was that negative 23 over 2? What is that? 27. Man, math is not my sonic suit today. Sorry. And I did this problem this morning too with some kids. I was thinking of adding the 5 and the 8. We okay on that? Now, to undo the squaring, I have to square root. So we take the square root of both sides, and I have x minus 2 is plus or minus square root of negative 27 over the square root of 2. Now, I know I have to move that negative 2 eventually, but I'm going to worry about that after I simplify the radical. Negative 27. Can I simplify that? Is there a perfect square hiding there?
9.
It's 9. So what's the, if I wanted to just simplify the square root of 27, what would it be?
9.
It'd be 3 root 3. Okay? So in this case, since it's negative, it would be 3i root 3. So right now, my numerator is plus or minus 3i root 3, but I'm still over the square root of 2. Do you remember the trick to simplifying radicals if you forgot?
Times it by the square root.
Divide by x.
Divide it, yeah, divide it in your calculator. If you take your calculator and you go to your y equals and you just do 27 divided by x squared. When you go to your table, you're looking for the smallest value of y that's still an integer, and that's what stays underneath the radical, and the number here is what goes out. So it's 3 root 3. That's how that works. Nice little trick. Okay. So now, how do I get rid of the radical of 2 in the denominator? What do I have to multiply?
By negative 2.
By root 2 over root 2. So now, your final answer becomes x equals, I'm going to move my 2 plus or minus 3i root 6 over 2. And that's your solution. I think the solution sets on here, we're splitting it into the 2 parts. 2 plus 3i root 6 over 2.
You forgot to times it by 2 from the beginning.
Yeah, would it be 2 root 2? Is it over that?
It would be 4 plus or minus 3i. Because you divide
They have it
all
with,
by
they have it with the
2.
fraction over. Yeah, what they did on that, what they did here is they combined it with a fraction over everything. That's why they have this 4 plus or minus 3i root 6 over 2. This is the same thing. It's the same thing. Oh no, we don't use decimals. Use fractions. Yes, sir.
Will there be
We'll have completed the square on the test. Yes. I mean, I don't remember. Yes, sir.
When you were solving, you just left it as the square root of negative 27, and then when you go to multiply by root 2, you get square root of negative 54 square minus.
Yeah, you can do that too. That's fine. I just saw the 27 and I did it right away. You can do it that way. There's nothing wrong with that. There's nothing wrong with that at all. Okay? What else on completing the square do you want to look at? We all right on those? Yes, sir.
Wait, so it can be 2 or 4?
Here's what happens. The solution sets that they were giving you is that they got a common denominator and rewrote it out like this. Because this is the exact same as that, because if you break this apart, you get 4 over 2 plus or minus 3i root 6 over 2, which is that. I don't put my answers like that because it's already kind of simplified here. It's not a big deal.
Can we do a factor?
Yeah, we're getting there. Are there any other completing the squares that you got completely lost and terrified and scared and had to go run and hide? Like a Patrick quarterback.
Are the numbers going to be this ugly on the test?
I don't know.
I don't like it.
I don't know.
Makes me
All right, what about factoring? Which one do you want to look at with factoring?
6.
Can't say all of them.
6.
6? We'll start with 6. On 6, negative 38 plus 24x equals negative 3 minus 35x squared. Once again, I'm going to make my x squared values positive, so I'm going to move everything over to the left-hand side. I get 35x squared plus 24x minus 35 is 0, which means I have to factor something that looks god-awful. So here's what we want to do. What's 35 times 35? 35 squared. Yes, very good, Captain Obvious.
1225.
So it's 1225. So we have to figure out all the factors of 1225 that add up to that multiply to 1225 and add up to equal what? 24? Very good. Easiest way to do that. And you're fine. And that's you got that far. Now you've got 4 terms, right? Group them. So you have 1225 over x. You guys remember that shortcut to help figure out factors?
Yeah.
Now, in here, if you scroll through on your table, you will come across eventually a 24 and 49, or 25 and 49, I believe, right? Eventually. There we go. 25, bless you. 25 and 49 are my 2 terms. So,
What did you type in the calculator?
1225 over x. That'll always give you your factors, and you're just looking for the positive, you're looking for your integers. Okay? So what happens then is you have 35x squared minus 25x plus 49x minus 35 is 0. When you go to that, what we call split middle term, you're factoring by grouping. What is the GCF of 35x squared and 25x? 5x. I'm left with 7x minus 5. What is the GCF of 49 and 35? 7. Factor out the 7, and I have 7x minus 5. Are these two the same? Write it down. And what's left? So your zeros of this, for solving wise, then are 5 over 7 and negative 7 over 5. If those were slopes, they'd be perpendicular. Yes, sir?
For quadratic formula, does A have to be positive?
No, it doesn't have to be. A can be anything. It can be positive or negative when you're using quadratic formula. Because all you're using is direct substitution.
Well, when I did 14, there I subtracted 2, and they're all negative.
Okay.
I got the wrong answer. And then 16, it was the same one, but I times it by negative 1, and I got the answer.
But I bet you what you did is you probably did something in parentheses. I bet you that's all it was. Seriously, it's usually all it is on that. Yes, sir. I'll show you 14.
What happens if it doesn't use a different way of solving it?
You'll get it wrong because you're not reading directions.
We use other
But what do we get
It'll tell. The test tells you when to use what. Okay. I don't care. There's only a finite amount of time. I think the test is only 14 questions.
Oh, that's
Yeah, it's not very long. It's not that long at all. All right. Any other factoring ones? What's the next factoring ones? I'm going to get to 14 here in a second.
Number 8.
8, yeah. 8. 10x squared minus 202 is 25x plus 8. Move those guys over. I get 10x squared minus 25x minus 210 is 0. What's your first rule of factoring? Well, this one doesn't work as cleanly because of the 5.
You can do it.
I factor everything out by 5. I get
2, 5, and 42.
45.
G2
For
what I had.
Excuse me. Is that right?
Yeah.
42. Okay. When I do this, now it's a little bit more manageable. What are the two numbers I have to multiply? 2 and 42. So, what are your factors of 84 that you can add together to get negative 5? You're looking for factors of 84, negative 84, to add together to get negative 5.
So like,
12 and 7.
and this.
What is it?
12 and 7.
Negative 12 and 7? Oh, what was that?
You can just put negative 84 divided by
Where did you
Yeah.
get the 84?
What's 2 times negative 42? There you go. So once again, I'm doing this by grouping. Since I'm solving this for my zeros and I've factored out the 5, do I need to do anything else with that 5? If I divide both sides by 5, does it just go away? Because what's 0 divided by 5? So do I need to rewrite it? So now I have 2x squared minus 12x plus 7x minus 42. Why do I always write my negative value when I split that middle term out first? Do you guys remember? Signs line up. Signs line up, it's a little bit less tricky if you're one of those types of people that forget signs. GCF here is 2x. GCF here is 7. And I'm left with 2x plus 7. X minus 6 gives me zeros at negative 7 over 2 and positive 6. Did you have to factor out the 5 to start this problem? No. Could you have still gotten the exact same solution sets? Yes. Because if you use that trick of 10 times negative 210 to get 2100, what times what's negative 2100 to add together to get negative 25? If you go through your tables in your calculator, you're still going to get the factors. It'll still work. Okay? It will still work. All right. What else? Anything else on the front page?
Do one of the bottom two of those, please. Do 10. Please.
Number 10? 15x squared minus 11 is negative 475. Once again, that means I have to add the 11. 15x squared is 464, negative 464.
Yeah.
Divide out by 15. And I don't believe you can simplify that. Not divisible by 3, right? Yeah. That one will not simplify from that fraction, right? Okay. Now you have to take the square root of both sides. X equals plus or minus the square root of negative 464 divided by the square root of 15. When I'm working with these fractions, and I know I have to take the square root of both of them, I'm writing it as square root of the top, square root of the bottom, just in case there's something that might simplify. 464, is there anything I can do with the 464? I know I have to worry about an I here, but what worked? 4i root 29, perfect. So I know that the top is going to be plus or minus 4i root 29. The bottom part, that's what 464 simplified to. The bottom part is still that ugly root 15. From there, I have to multiply the top and the bottom by the square root of 15. So you are going to get a horrible looking fraction. I don't know what 29 times 15 is, but it's probably a number.
435.
How much?
435.
435. And I just leave it. And that's it. That's how I rationalize my denominator, multiplying it by the radical. Okay? Multiplying it by the radical. 14 for the quadratic formula. Negative 3x squared minus 8x equals 2. So I have negative 3x squared minus 8x minus 2 is 0. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Fill in the blanks. Opposite of b, so it's 8 plus or minus the square root. 8 squared is 64 minus 4 times negative 3 times negative 2 all over 2 times negative 3, which is negative 6. Okay. So now I have 64 minus 64 minus 24. Right? So 64 minus 24 is 40. So I get 8 plus or minus the square root of 40 over negative 6. Square root of 40.
2 squared root 10.
Good. 2 root 10. Doing that. So I have 8 plus or minus 2 root 10 over negative 6. What can I do to all those numbers? Divide everything by 2. If I divide everything by 2, my final result should be 4 plus or minus root 10 over negative 3. And that would be my solution. Did you miss a sign?
Yeah, it was the 24 I added.
There you go. Yes, sir.
Okay, so when do you want us to actually calculate it out and say the answer could be negative 1?
The only time you have to do that is if you wind up with a solution that looks like this.
Okay, so if there's ever a square root on that.
Just leave it. Yeah. Yeah, just leave it. Okay. And to be honest with you, if you left it like that, I'm not going to yell at you. I might give you the fish shape, but I'm not going to do it. Yes, ma'am.
Oh, I guess it doesn't matter.
Oh, you put the negative on top. That's fine.
And the,
Yeah, if you put the negative on top, it's not big deal. Works the same.
So you put this in the table and
What else on the second page?
GCF.
let's see.
Yes.
20.
20.
I got the answer, but it wasn't the same as, like, I got P minus 9, but the answer was 9 minus 4.
P minus 9, 9 minus P. Oh, okay. So you have 567 minus 26P. So what's the first rule of factoring?
5 by 7.
GCF divide out by the 7.
81.
81.
18. And just 1.
All right, so this is just in reverse. If this is, you see how your signs are alternating? You have positive and then a negative. So, oh, excuse me, they're both positive for your ends. 81 is positive, the p squared is positive, but the middle value is negative. So they both have to be negative, right? So that means if you're putting it in this order, it would be 9 minus p, 9 minus p times 7. That's why.
But does it matter if I get it P minus 9 because I just rearranged that so that?
No, that'll work. It's the same thing, because you put it in descending order, it's not a big deal.
Couldn't you just put 9 minus p squared?
Yeah. Yeah, if you wrote it like that, that's fine. Yeah, because you just put it in descending order, you're getting the same result. I would probably have done that.
Can you just run through how to do like 18 real fast? Like,
Ah, yeah.
That's like
It's
the
one of
one
those
where you
trick
notice-
ones. It's the trick one that everybody always forgets. That's why I was putting them on here. Is that a perfect square?
yeah.
Is that a perfect square?
Yeah.
Is that a subtraction symbol? What's the square root of 49?
7.
What's the square root of 9?
And then so it's just plus.
Yep. Whenever you have two terms and they're both perfect squares and it's subtraction, it's called a difference of squares. You get alternating signs because that middle term disappears.
Alright.
Okay? Ah, speaking of middle terms disappearing here. Disappearing? That made up a new word. That was pretty cool. I did want to briefly touch on working on I real fast. Let me get one more here.
What is the, that one's called the difference of squares?
Yeah.
What about the one that's still just
Completing the square.
That's when you just factor. If it's like 8x squared minus 16x, take out the GCFs. That's all it is. Always go for GCFs first. One thing that was not on here, graphing. Remember, when you're graphing these things, make sure you plot your vertex, some symmetric twins, some zeros, solid or dotted line, and which way are you shading. I'm hoping that wasn't so bad. I remember when we did the graph shading, you guys were okay with that. Yes, ma'am? Yeah, I'm going to do an imaginary one. What do you got? Because I don't have imaginary on here. I just want to make sure I show you.
I'm having trouble with 13 through 16. Like, I figured out 14 was as we were doing it.
Okay.
But I think I'm having, like, I'm doing the formula, like, I'm setting up.
All right, remember, on 13, you should get, when you move stuff over, did you get that for your equation?
Yeah.
Okay. If you're having it with quadratic, sometimes if you're not sure if you're getting weird values, you take 1 extra second to label what your A, B's, and C's are. Sometimes it forces you to put them in the right spot or not mess up a sign. So you get the opposite of B. It's opposite of B plus or minus the square root B squared minus 4AC all over 2A. So fill in the blanks here. We get opposite of negative 10 is 10 plus or minus the square root. 10 squared is 100 minus 4 times 3 times negative 18 all over 2 times 3, which is 6. When I do this part, though, when I go to my calculator, put the discriminant. Remember, the discriminant is all the junk underneath the radical, right? And what does the discriminant tell you?
It's two numbers imaginary or.
Yeah, it tells you your number of solutions and what type, number and type. So here you wind up with 100 minus 12 times negative 18, which is some number.
216.
216, so it's 100 plus 216, so you get 10 plus or minus the square root of 316 over 6, and then it's just a matter of simplifying it from there.
What question?
That was 13. Does that make, were you missing signs?
I don't know. I guess when I put
Yeah,
it
I-
in my calculator, I just put in, negative 10 squared minus.
There's your problem. You didn't put parentheses around the negative 10.
Wait, so why is it?
You have to put, if you're putting it directly in your calculator, the negative 10 squared, it's squaring the 10 and negating it. You have to put parentheses around it. That's why you're getting the problems wrong. Did you notice when I do this, I say what is 10 squared? I'm getting rid of that negative right away because I know it's going to become positive. So if you get in the mindset of when you get into the discriminant part, the b squared, if your b value is negative, just think to yourself, I have to square it to become positive. Or put it in parentheses. That's exactly what you're getting wrong. And that's what happens a lot of times.
Can you do an example?
Yes, sir.
For graphing, is there gonna be like slope, vertex and, all those different forms?
When you had like 5, 8, when you had to write out the equations?
Yeah, like, is there?
Yeah, you have to do that. We don't have to graph it, we just have to write out the equations, just like we did in 5, 8.
Okay, and we're gonna do that basic picture?
Yeah.
Did you see?
Yep. In this case here, your first rule of factoring is GCF.
Wouldn't you like the graph just times x, not x be 0?
Then you send both equal to 0. You get 0 and 2. Imaginary, real fast because we're running short here. Imaginary, if you have to simplify an imaginary term. Very good. I have to multiply it by 1 plus 4i to the top and bottom. My denominator, since it's alternating signs, becomes 1 minus, well, what's 4 times 4? 16. I times I. And what is I squared always equal to? Negative 1. So this becomes 1 minus 16 times negative 1. You all right? What happened? Oh. And then what's 1 minus negative 16? 1 minus negative 16? 17.
Oh, negative 16.
So the denominator becomes 17. And then you FOIL out the top and work your way out again. So you have 2 plus 8i plus 3i plus 12i squared, which is minus 12. So you get negative 10 plus 11i. Okay. Remember, that last section we did of 5-8 when we were doing some of that modeling, you will have to be able to write the equation of in standard form or in vertex form or intercept form given those values again. That was 5-8, and you guys flew through those. You guys did great on that. Those were similar to, let me pull that open. Let's see, that was 5-8. I don't have a 5-8 problem. I don't have a 5-8.
Can't forget to show us the video.
I know. I might just have to put it online.
It's better than before. It's not as bad.
Remember, if you had to do a problem like these, you guys did really well on this. If you had to write this into vertex form, give it a point to vertex. You have to remember what vertex forms look like. Y equals A x minus h quantity squared plus k. This gives you your h, k, x, and y. H, k, x, y. What do you have to solve for? And then just resubstitute it. Okay. Also, don't forget when you're working with sets, the 3 sets of ordered pairs. When we set it up as the matrix, this first column was your x squared, the second one was the x values. What was in that third column? Ones, and this was your y values. And that was just straight to get your A, B's, and C's.
Just gotta look over.
Inverse matrices.
Should be fine.
The greatest thing ever invented, right? Okay. If I were you guys, I'd go through my chapter review, my chapter test. It's right there in the book. Start piecing through some extra problems. These were real tough. The completing the squares and the factoring, some of these things are pretty nasty on here. I tried to make sure that we have only X amount of time to take a test, so you can always think about how long you're going to have to go. You guys should do really well on this. You should do really well on this. Okay? You should. All right. I have the review up online for you guys here later. I just recorded what we just did. Hopefully it'll work. Ooh, 40 minutes, that's a long time.